We started with areas related to circles. Okay, Hani is also here with us. Yasindi, you completed areas related to circle in school recently, right? That
Yes.
was your last chapter. Are you done with areas related to circles in
Yes.
school? Yeah.
Yeah.
And the only chapter that was left was surface area and volume, right?
Yes.
Okay. All right, so we started circles, areas related to circles in the last class, yesterday, day before yesterday's class or yesterday's class. So we will do some questions from the exercise today. So if you have any doubts, okay, I did ask you guys to, bring your doubts from areas related to circles since the chapter is pretty much easy for everyone. So do you have any doubts in areas related to circles? Everyone? Anyone can share their doubts, ask their doubts. If not, then
No, no, sir.
no. Okay. And what about Yasandi? You just completed the chapter. Any doubts from your end and any questions?
No.
No, no any areas related to circle. Saad and Zeb. Saad, what about you?
No, sir.
No.
Not
Zeb, did you complete areas related to circle in school, Zeb? I can't hear you, Zeb. Can you type out your answer if I can't hear you actually? No one can hear you, I guess. Uh, and Hani, did you guys start areas related to circle, Hani, in school? Or what's
Yeah.
the state? So is that the current chapter, areas related to circle?
No, we finished it long back.
Long back, okay. So how did you find the chapter? Easy? Do you have any doubts right now from areas related to circle? Did you take any
No,
questions?
it's pretty much easy. I just need practice.
Okay, all right. And Zeb is also doing that chapter currently at school. So, okay, let's look at a few questions then. So up until now, let me just write down what we are done with. We completed triangles. Okay, we completed Yasindi and Hani haven't done this with us here. But let me just write these down, the chapters that we have completed so far. We have done coordinate geometry too. Who just left? Coordinate geometry, applications of trigonometry. And then we were done with circles. And then now we are at areas related to circles. Okay, so just a moment. Okay, everyone is here, right? No one left. Okay, is my camera on? Or
Yes, sir. Your camera is on.
yeah, it is on. Okay, so what do we do today? All your inputs are welcome. Because areas related to circle, to be honest, we can skip that chapter because it's easy. It's a very straightforward chapter. Everyone can do that. So instead of taking up doubts or trying to solve very simple straightforward questions that are given to us, we can do something else today. We have done these chapters so far: coordinate geometry, triangles, trigonometry, applications of trigonometry, circles, and areas related to circles. It doesn't mean that you can't ask your doubts later on in the classes, related to circles. You can definitely do that, but I don't think it's going to be worth our time to, solve those questions, hand in hand again. So any input from anyone? Anyone can, tell me. Our plan here was, Yasindi and Hani, our plan here was to, cover geometry first and then after that move on to, algebra. So that was our plan in school. That was our plan here. So let me ask Zeb. Zeb, do you think we have to do all the questions here? Because I didn't ask you that since you're doing that chapter in school. You can respond in the chat, but yeah, do respond in the chat if we should do the questions here. Did you guys solve this particular example from applications of trigonometry? Example number Example number 6. If you guys have your NCRT with you, look at example number 6. Have you guys done that? That's a good question to understand the whole chapter, to be honest. Let me know who has done that, who hasn't. And Zeb, until then, let me know. Okay, so Zeb is also on page with starting a different chapter. Who just said something? Okay,
I
Umair has
asked you
a.
can
You did.
can show the question because I don't have the textbook.
Okay, let me copy the question then. Do have your textbooks with you when we start the class so that it's easier for us to, look at them. Okay, so this is the question. Since everyone can see this question, now do let me know. अगर से किसी ने किया है नहीं किया है, we can take this up.
I have done this question, sir.
You have done this. What about Saad, you?
No, sir.
No? Zeb, did you do it? Yasindi, did you do it? Okay, Zeb has also not done it. Yasindi, did you do this question? Or have you done this in school?
No.
No? Hani, what about you? Did you do this one?
No.
No? Okay, so everyone has doubts in applications of trigonometry. Everyone gets stuck somewhere. So we can do that. We can sort of revise applications of trigonometry today and take up a few difficult questions. Okay, so let's start with this one, applications of trigonometry. So over here in this question, the diagram is going to be the most difficult part if you're not good with making angles here. So let's do that. So over here, we are given that angles of depression of the top and bottom of an 8-meter tall building from the top of a multi-storied building are 30 degrees and 45 degrees respectively. So we are talking about two buildings here, first of all, right? So there is this one building that is 8 meters tall. So let's make that 8-meter tall building. So this is our 8-meter tall building. Okay. And about this 8-meter tall building, we are talking about another building which is multi-storied. So of course it's, taller than this building. So the first statement that is given, the angles of depression of the top and bottom of an 8-meter tall building. So angles of depression to the top of this building and the bottom of this building are being made by some other building which is taller than this building, and the angle of depression to the top is 30 degrees and to the bottom is 45 degrees respectively. Okay, so let us start to name this figure first of all as we go about it. So this much is clear from this particular line that the angles of depression of the top and bottom of an 8-meter tall building from the top of a multi-storied building are 30 degrees and 45 degrees. So there's another multi-storied building. So there is this other building here. Okay. Now let's name this building CD. This is the multi-storied building. Okay. Now, since we are in an ideal world, we are going to assume, and which is going to be true, that B and D are meaning AC, AB and CD, both these buildings, AB building and CD building are on the same base, right? They are on the same level of ground. Okay, now we are being told that from the top of this building, okay, from C, this is the top of this building CD. From the top of this multi-storied building, we are measuring angles of depression to the top of building AB. To the top, the angle of depression is 30 degrees. Now, how will we make that? So to first of all make angles of depression, we have clarified this thing that we'll first make a horizontal line to the top of whatever figure we are standing on. So we are standing on top of the building CD. From this top, we are making an angle of depression to the top of building AB, and that is going to be 30 degrees. Okay. So over here, this angle, first angle is going to be, this is going to be angle 30 degrees. This is going to be our angle of depression. Okay. So when we have made this, we can also do one another thing to start making a triangle. We can make a base for this building AB, right? We are measuring this side. So when we are measuring, when we are, taking a parallel line, when we are extending a base from this building stop, AB building stop, this is going to intersect at this point E. So can we say that this is going to also be 8 meters, the tall building, the building which is 8 meters tall. If we are standing on top of that and we are measuring the height of the building opposite to us, imagine we are standing, two people are standing. This is me, right? This is Taha, and behind me there is my friend, let's say Ashi. Okay. Now I am 5 feet tall. I am, let's say I am 6 feet tall. Today I feel like 6 feet tall, and Ashi is 5 feet tall. Okay. So if me and Ashi both are standing side by side, and I am 6 feet tall, and Ashi is 5 feet tall. Okay. So this is TA and this is AH. Okay. Can we say that this particular point AS will be equal to AH, which will be 5 feet? Right, with that logic, we are saying that this part of this tall building, this whole tall building, multi-storied tall building, which is taller than the building AB, is going to be 8 meters. Is that logic clear to everyone? If someone had a doubt in
Uh,
that, mm-hmm. Go ahead.
no, sir.
No, sir.
No? No? Okay, Yasindi and Hani, what about you guys?
No, sir.
No? Okay. Um, all right. Okay. I hope Zeb, it's clear to you also. Let me just check on you. Yeah, okay, it's clear to Zeb too. Okay, so we are clear up to this point. So this angle is going to be 30 degrees because of the angle of depression made by the top of the building to the top of the building AB is 30 degrees. Now we have another angle of depression that is being made by the bottom of the building. Okay, so let's just a second, my pen. Okay, so this angle would be 45 degrees, and over here let us join the bases. So this angle would be 45 degrees. Okay, so we have two angles now. So just for clarity purpose, let me split them and make them clear. We have a first building AB, 8 meters tall, and a multi-storied building CD. Okay, we are projecting a line from this, and this is going to be a point E, and this is a 30-degree angle, and this is going to be a 30-degree angle. Okay, so we have this, and then we have another figure. Okay, so over here, what we can say about triangle ACE and triangle BCD. Okay, now we need to find the building's height completely. The question asked us to find the height of building, height of the multi-storied building, and then also the distance between the building AB and the multi-storied building. This is what we need to find, and over here we can observe it very clearly that we need to find this x part. Okay, Okay, this X part, this X region is what we need to find, because we are already aware that the building's height is going to be CD is going to be equal to CE plus ED. Over here, CE is the unknown part X, ED is going to be 8 meters. Okay, so how do we do that now? Over here, in triangle ACE, we can say that tan 30 degrees is equals to CE upon AE. Okay, and in triangle BCD, we can say tan 45 is equals to CD upon BD. Okay, now over here we have no clue what CE is, because CE is X. We have no clue what CD is, because CD is a component of CE and ED, which are both unknown. And now we are also not aware about what AE is going to be or BD is going to be. Okay, but we are, so basically we are going to be stuck here if we do not make this one observation, that AE will be equal to BD. Okay, this side, this whole distance between two buildings AE and BD is going to be the same thing in the both triangles, and both of these triangles ACE and triangle BCD, because they are on the same base, right? Triangle ACE is also on the same base and triangle BCD is also on the same base. AE and BD basically is the distance between two buildings, right? Now, if you measure that distance from the bottom, that would be BD. If you measure that distance from the top, that is going to be AE. Okay, and that is going to be same. So if that is going to be same, we can use that thing and we can say that AE is equals to CE upon tan 30 and BD is equals to CD upon tan 45. Okay, and since this is 1 and this is 2, 1 and 2 are equal because they are one and the same thing, we can equate CE upon tan 30 is equals to CD upon tan 45. Okay, tan 30 is again root 3. So that would mean root 3 into CE is going to be X. That is what we, gave it. And CD is going to be our complete height here, right? And CD can be written as, over here, what we wrote CD as X plus 8, right? So let's write that, and tan 45 is 1. So over here, we have something 3 root 3x is equals to x plus 8. Over here, if we do something about the variables, root 3x minus root 3x equals 8. And if we take out x as common here, that would leave us with root 3 minus 1 equals to 8. That would give us x equal to 8 upon root 3 minus 1. Okay, so we are here with this value. We will have to rationalize this. Any doubts so far?
No.
No? Okay, so let's continue. Feel free to, stop me and ask any doubts you have. We are a lot of people here, so don't be afraid about, interrupting or feeling shy about anything. All right, so we will have to rationalize this. So rationalization would mean this. Root 3 plus 1. So this would imply 8 into root 3 plus 1 divided by, this would be 3 minus 1. This would give you basically 4 into root 3 plus 1. Can we say that directly? This 2 will be, uh, 8 will be divided by 2. So the value of x would be 4 into root 3 plus 1. So what is x here? X is CE. Okay, if x is CE, we know that the building site CD was CE plus ED. Right. So that was substituting this CE over here. This would mean ED. ED was 8 meters. So let's multiply this inside and write a common answer by simplifying it. So this would mean 12 plus 4 root 3. You can either leave it at here or you can either further write it as 3 plus 3 root 3. Okay. This is going to be the building's height, the multi-story building's height. Okay, and CE is going to be, we found CE. Now with that in mind, we can use CE. Now since CE is equals to 4 into root 3 plus 1, we can use either this or we have to actually use this AE. So over here, AE will be the distance between the building, distance between 8 meter and multi-storied building, MSB. So this would mean 4 into root 3 plus 1 upon into root 3. Okay, so this would mean multiplying this into this. So 3 plus root 3. Okay, so this is what we will get, distance between the two buildings. All right, so this is our answer here, distance between the two buildings and the height of the building too. All right, any doubts in this?
Both are same only, right?
No, yeah, both came out to be same. Let me just check the answer once then.
Yeah,
If
both are
we,
same only because tan 45.
yeah, tan 45 is getting involved, so both will be same. Yep. Right, so any doubts in this? It can be
No, sir.
anything. No? Okay. All right. So I remember this one question from the NCRT that I thought to be, difficult. So I took this and applications of trigonometry. Hmm. What about the proof of BPT? Anyone, any problems in the proof of BPT? Because that question is going to be a question that if comes in the exam can be scored very easily. How many have someone told me yesterday that they memorized the whole proof of BPT. I don't remember who that was, but good for them, whoever that was. I think it was
I did.
Yasandi, right? Yeah, it was
Yeah.
you. Okay. Yeah, that is good. What about others? Do others remember the proof of BPT? BPT is going to be a very important proof in
Yes.
exam. Yeah,
Yes, sir.
okay. Omer remembers it. What about you, Saad? Do you remember the proof of BPT?
No, sir.
No? Okay. What about Hani?
Yes.
Okay, so you know the proof of BPT. Okay, so we have
Yeah.
three people who know it. And Zeb, what about you, Zeb? Do you know the proof of BPT? Yep, okay, Zeb also knows. Okay, so only Saad doesn't know. So let's just take it very quickly. It's very easy to be honest. There are just three lines that you need to remember in that. Okay, so in the proof of BPT, we have a triangle with us, right? Triangle ABC is given to us, and we are being told that there's a line DE. This is a given statement to us. DE is parallel to BC. This is the true statement or truth. And the implication for this was that AD upon DB is equals to AE upon EC. Okay, we need to prove this. Okay, so to prove this, we will have to make a few constructions here and very simple constructions. So the first construction would be to make a perpendicular from D to the side AC, and we will call this as Y or anything that you want. Okay, we will be constructing these two perpendiculars. All right. Now, after constructing this perpendiculars, we will also join side BE and side CD. Okay. Now we need to prove AD upon DB is equals to AE upon EC. So this particular thing lies on this particular side. Let's name this uh, side 1, and this particular ratio side 1, and this one lies on side 2. Okay. So if we have this, we will have to, what we will do here, we will be using areas of triangles. Okay. So first of all, we will be looking at area of triangle ADE. Okay. Area of triangle ADE. Uh, so to write area of triangle ADE, that would be half into base into height. Right. So to write the proof here, half into, when we are looking at triangle ADE, what is the base here? Side AD. Can we say that? AD is going to be the, base of this triangle AD. And we can say that the height is going to be EX, since EX is the perpendicular here, ADE. Okay, right. And then what about triangle ABE? Uh, ABE, and there's another triangle. Okay, we can also write this another way to write this. Okay, so this is going to be one equation one, and then area of triangle ADE in a different way will be written in the context of this base AE. Okay, and over here we will be using the base DY. Okay, the height DY. Over here this is the height EX. Over here this is the height. Okay, dy. All right, and there is one another triangle. Which triangle are we going to take? Triangle ABE, triangle ABE, ABE. So let me just look at the triangles. I forgot which triangles to take. Just a moment. If anyone remembers, Yashanti, which triangle are we going to take in this? The another one? We will take another triangle's ratio, another triangle's area too.
DBC.
DBC. Okay, DBC. Just a moment. Let me also have. Okay, we will be looking at DBC. DBC. No, we will be looking at the area of triangle BDE and triangle DEC, right? These two, and then there is one last triangle BDE. TB upon EN. Yep, you're right. You're right. Yep, you do remember well. Yep, we will be looking at one another triangle that is going to be triangle BDE. Area of triangle BDE. Okay, so when we are looking at area of triangle BDE, over here the base is going to be BD, and the perpendicular that we are going to take, the height that we are going to take is going to be EX again. Okay, this, and then the last triangle that we are going to take is DEC. Okay, area of triangle DEC. So area of triangle DEC, DEC over here, EC will be this, and this will be DY. Okay, so far, are you following this, Saj, so far?
Yes,
That
sir.
we took 4 triangles. So why are we taking 4 triangles? We are taking 2 triangles on side 1 and 2 triangles on side 2. Okay. And now we are going to take the ratio of the 2 triangles in the way that we will have this particular thing on our end, AD by DB and AE by EC. And one particular fact I do not know, I'm just taking that from NCRT, but what happens here is that we are going to write, first of all, we are going to write this, that area of triangle ADE upon area of triangle BDE. When you write this, this would be half into AD into EX upon half into AE, half into BD into EX. So this would give you AD upon BD. Okay. And then if you take the area of triangle ADE, this is from equation 1, this is going to from equation 2, this area. Okay, upon area of triangle DEC. So this would be half into that side AE into dy upon half into AE into dy. This would give you not AE, this would be the side ADEC. So AE upon EC. Okay, now what is going to be observed here is that triangle BDE and triangle DEC. When we drew this particular triangle with us, ABC, we said that DE is going to be parallel to BC, right? And triangle BDC and triangle DEC, they are on the same base DE. Now NCRT mentions that reason, and that is why I'm taking it out, taking it at face value. I do not really understand how that works, but I will look at that. But for now, we can take it on face value that if these two triangles have the same base, the area of these two triangles will be same. Okay, so over here you can notice that we have area of triangle ADE over here, area of triangle ADE over here too. And since we just now made this, conclusion that area of triangle BDE is equals to area of triangle DEC, right? We are making that conclusion here based on the fact that they have the same base. So that would mean that over here, this ratio and this thing. Okay. So basically these two ratios that we wrote, they are both same. Area of triangle ADE divided by area of triangle BDE is the same as area of triangle AD divided by DEC. That means that these two things are going to be same, which is the ratios that we were supposed to prove, right? Which is AD upon BD is equals to AE upon EC. Okay. So this is the proof of BPT. All right. Any doubts, Sad?
No, sir.
No, you will start with the triangles. First of all, understanding which triangles to take, you will take the triangles based on the side 1 and side 2. And one thing to remember is the area of triangle ADE. You will have to take it with one particular base in equation 1 and other with the different base AE. Okay. All right. Anything else from these chapters that we can discuss? Hmm. You guys can also give me anything we can discuss here. We do have 20 more minutes left. We can start a fresh chapter from tomorrow, from the next class. Okay. Our next class is going to be on Sunday, right?
Yeah.
Okay, I'm not going to be available on Sunday. I will have to inform the team also. I have a friend's wedding to attend, so I won't be there. So we can use this time to, solve any doubts we have. Mm, Coordinate geometry. We discussed the problem from it yesterday. Triangles, we just took this particular thing here. And then we have, after this, we are going to take up surface area and volume. That chapter has a lot of information there. Okay. Mm-hmm. Anything, guys? It can be anything from any other chapter also, not supposed to be just from these chapters that are written here.
Sir, can we do statistics?
Statistics, it's going to be long, but I
No,
am
this second method, like assume method.
the step deviation method
No,
or
assumed method. Assumed
assume.
method.
I have to refresh that for myself, to be
Yes.
honest. And if we take that up, I won't be able to help you with that today. Let's take statistics on a different day. Is that what you wanted to discuss the other day? I think 2 classes earlier, you wanted to
No, sir.
discuss something.
No,
No?
no.
If
Yes.
it is not from statistics, then you can tell me that now and we can discuss that.
No, sir.
No?
No,
Okay,
I'm
it's
clear
all
with
right.
that.
Okay. So AP arithmetic progression also has a few questions that are good. And mhm,
How about we do a few questions on similarity of triangles?
similarity of triangles. Okay, sure. That's a start. Similarity of triangles. Okay, did everyone do example number 7? Let me just show example number 7 is a good application of similarity. Hani, I don't remember if we did this question together too. Let me know if we did this. We can skip this question. Example number 7 is a good question. Did we do this in the earlier classes? Did we do it or not?
Yes, sir.
Okay, we
No,
did it.
no, I guess.
You
No.
okay, you didn't. Okay,
Yeah.
I mean, of course we did, Omer. Saj and Zeb, we did take this up. Okay, so this is a good question for application of this particular similarity part. So let's discuss this, and then also I usually take this question and example number 8 because these are two very good questions to revise the whole similarity part and the lengthy parts. Okay, so let's take this up and solve this soon. So over here we are given that there's a girl of height 90 centimeters who is walking away from the base of a lamppost at a speed of 1.2 meters per second. If the lamp is 3.6 meters above the ground, find the length of a shadow after 4 seconds. Okay, so whenever we are solving these questions, the first thing that I would always advise is to convert the given distance, given um, details in the same unit system. Over here, 90 centimeters, 3.6 meters, 1.2 meters. So we need to convert it into the meter metric. So 0.9 meters is the girl side. So over here, we have a lamp post which is 3.6 meters high above the ground, and AB is the lamp post over here. We have a very good figure. Now we are being told that a girl is walking from the base, walking away from the base of this lamp post. So she's walking away from the base and she walked for 4 seconds. Okay, at a speed of 1.2 meters per second. All right, so they have not given to us very clear directly that okay, they have the girl has walked this particular distance. They have instead given us the information in this way. So distance can be found from this particular formula from physics, basic formula, time into speed. So this would be d equals 4 into 1.2. This would give us 4.8. uh, yeah, 4.8. So the girl walked 4.8 meters away from the lamppost and then she stood still there. And we need to find the length of a shadow after she walked 4.8 meters away from the lamppost. So this is going to be 4.8 BD, and the length of a shadow when she's standing at the point D after 4 seconds, that is after walking 4.8 meters, we need to find that particular length of a shadow. So over here we have this particular information, the girl's height, the lamppost height, 3.6 meters, and we need to find the x height, the x part. So what will we do here? The triangle that is given to us very clearly can show this thing that we will be using some kind of a similarity to find the distance here, the DE part. Over here, if we observe, we have two triangles, triangles ABE and triangle CDE, right? ABE and CDE. Over here, if we want to find the side DE here, DE part, we need to observe that we will have to observe one thing, that it is made up of this particular thing. Okay. Over here, BD is known to us 4.8 meters and DE is X and BE is a part of this triangle. Okay. Now, if we have to prove the similarity somehow, and we will use that. Okay, of course, we'll use that. So before that, let us observe what kind of relationships we can form here. Between the sides, the relationships would be very clear. The sides will be in this ratio. The triangles are going to be similar in some way. So AB by CD and then BE by DE, and then the last thing AE by CE. Over here, as you can notice, AE and CE are completely, inconsequential in this question. Nothing of use is going to come out of, using this particular thing. So we will have to prove the similarity. And over here, AB is 3.6, this is 0.9, and BE is going to be 4.8 plus X and this. Okay. So if somehow we prove the similarity, that these triangles are similar, this particular relation in the sides ratio side can give us the value of x. Simply solving this particular thing will give us the solution. So how will we prove the similarity of these two triangles over here with us? So let us make the triangles here and see what we can do. So this is triangle ABE. And this is our triangle CDE. Okay, so over here, what we can notice is that uh, two angles are 90 degrees here, right? And angle B is equals to angle D, that is 90 degrees. Okay. In terms of side, you can do nothing here because this particular side is not given to us. Okay, and we have only, we have this side given to us 3.6, this side given to us 0.9, and this is BD. No, this is BE. Okay, and this thing. So in this combination, we cannot use SAS, triple S, right? So using sides is going to be out of the question here in terms of similarity. Now we have two angles that we have proven here that are same. Now angle E and angle E are both the same angles in triangle ABE and triangle CDE. They are literally the same angles, right? So angle E is going to be same. And if we have two angles which are same by angle, we can say that the two triangles are similar by angle criterion, right? So triangle ABE is similar to triangle CDE by double A criterion of similarity. Okay, is this clear, Hani?
Yes, sir.
Yeah. If anyone else has any doubts, do let me know. Okay, so this is the case. So now that they are similar, now we can say that this holds true. Right now, since this holds true, we can calculate it. We can calculate the length of a shadow. So this is going to be 4 equals to, this is going to be 4.8 plus x upon x, right? So this would be 4x equals to 4.8 plus x, and this is going to be 3x equals to 4.8. X will be equal to 1.6 meters. Okay, so the girl's shadow is going to be of the length 1.6 meters. This is how we will solve this question. Okay, is this clear?
Yes.
Okay, so one another question that we can take here about medians and altitudes that are going to be involved. Let's take, are you clear? Is everyone clear about what is a median and an altitude? If not, let me just quickly describe what a median and altitude is. Is everyone clear about the concept of medians and altitude? If you are, then let me know. We can skip the part of, explaining what they are. Is everyone clear?
Yeah.
Median,
Yes, sir.
yeah. What about you, Hani and Yasindi? Are you clear about what is a median and altitude?
Yes.
Yep. Okay.
Yes,
So
sir.
let's, yep. Okay. So let's move to the question then. So we have two questions over here. Question number 6.37. Okay, over here, these two questions are of the same type, 6.37 and 6.38, the figures that are a part of this. So over here in 6.37 uh, and 6.38, it is going to be a very repetitive question because the solution is very repetitive. One thing is going to repeat again and again. So in 6.37 and 6.38, let's look at 6.38, seventh question. So over here, we are being told that AD and CE are altitudes of triangle ABC. Okay, and they intersect at a point P. Show that triangle AEP and triangle CDP are similar. So triangle AEP is similar to triangle CDP. This is what we need to show. And this is the figure that we are looking at. So if we look at this particular figure, triangle AEP is going to be this triangle. Triangle AEP is going to be this triangle, right? And CDP is going to be this particular triangle over here. So in terms of side, we are given no sides, no measurements of sides. So we cannot really use SAS or SSS at the moment here in this one. What about angles? Let us look at angles. What can we say about angles? Over here, we can say that angle E is equal to angle D, which is 90 degrees. Okay. Now, what about one another angle? Which is going to be that angle? If someone knows it already and has solved it, don't say. Let someone who is confused or is figuring out the question, let them say. Okay. So what is going to be one another angle that we are going to take to prove the similarity of these two triangles? Hani, what do you think? Which angle do we take here now? Which particular angle do you think? I can give you one idea. Vertically opposite angle. There is a vertically opposite angle in the formation of triangle AEP and triangle CDP. Can you see that vertically opposite triangle?
Yeah,
Which angle is it?
APE and CPD.
Yep, exactly. So angle APE is equals to angle CPD, which is going to be vertically opposite angle. So because of these two angles, we can say that these two triangles are similar. Okay. Now, similarly, triangle ABD is similar to triangle CBE. Okay. So to prove that, we will use something similar again. So triangle ABD is going to be, can I just a moment, it got stuck. Okay, so triangle ABD is going to be this whole triangle, and triangle CBE is going to be a part of this. So over here, as you can see, angle E is equals to angle D is equals to angle D in triangle ABD and triangle E in triangle CBE. They are both 90 degrees. Now, what about one another angle or one another side? What are we going to prove here is going to be equal? Which other angle is going to be equal here so that we can prove the similarity of these two triangles?
Angle B is equal to angle B common.
Yep, that is the common angle. Angle B is present in triangle ABE over here, right? And then in triangle CBE2, we have angle B, which is a common angle. Okay. So because of that, we can say that these two triangles are again similar by triple A and double A, right? And then similarly, you can prove that for AEP and then this particular one and this particular one. It would sort of be repetitive to solve them. Okay, but this is how you will start to look at the similarity part. Okay, which one we are going to use or which one we are going to avoid much better way. Okay, let's look at figure 6.37. In figure 6.37, we are being told that triangle ABE is congruent to triangle ACD. Okay, so triangle ABE is congruent to triangle ACD. So that would mean side AB will be equal to AC, side BE will be equal to side CD, and side AE will be equal to side AD. Right? This, and then angle A is equals to angle A, angle B equals angle C, angle E equals angle D. Right? This is what it means when they are congruent. Now we are being asked to show that triangle ADE is similar to triangle ABC. Okay, so triangle ABE, triangle ABC. Let me draw this. Triangle ABC is going to be a bigger triangle. ABC and triangle ADE is going to be a triangle inside it. Okay, no. This is ADE. All right. So how do we do that? The first thing that comes to mind, since we were thinking about angles all along, angle A will be equal to angle A. That much is true about it, right? And what about the sides? Since we cannot use any other angles here, can we use any other angle here from the given, angles? When we said that angle B was equal to angle C, what we meant by that was angle ABE. Let us, write that clearly so that it will help us. When we said that angle ABE equals to angle ACD, right? And when we said that angle E and angle D were equal to each other, what did that mean? So this was angle D and angle E were equal. So angle ADC, angle, just a moment. Let me just, AEB equals to angle ADC. Okay, this is what we meant about the angles. So over here, we have this with us now. So angle A is equals to angle A. That is true. That much we can say about the given information. What about angles D and E? Can we make any conclusions in that? Can we say that angle ABC is equal to angle ADE? Can we say that? Is there any way to do that? Hmm, ADC. All right, I don't think we can do that, and we cannot say about angle ACB equal to angle AED. Hmm, ABE, ACD, AEB, and ADC. All right, so we cannot say anything about these two angles. What about sides? What about sides? Can we say to prove that this is the case, we need to prove that AB upon AD is equals to AC upon DE equals to BC upon DE. This is AE and this is DC, DE. Can we say something about this? Can we use, can we say this via this particular thing? Mm, mhm. Any ideas, anyone? That is, that can be used. Even I am sort of stuck and exhausted right now. Can't think of anything. Can we use AB upon AD? Right, AB upon AD, that would be AC upon AC upon AE, and then okay, when we are given this, okay, we can do this thing. We have AB is equals to AC, right? And if we divide both of them with something equal, then they will be equal, right? If we have 4 and 4 on two sides, and if we divide both of them by 2, if we are saying 4 equals to 4 and we are dividing both of them by 2, that would mean that would still be 2, that would still be equal, those two will still be equal, right? Now to get what we are looking for, if we divide AB and AC by AD and AE, which are both one and the same thing, we can still say that these two are going to be equal, right? Can we make that assertion here? From this particular reasoning, since AB is equals to AC, we are dividing AB is equals to AC, 4 equals to 4 by equal parts, equal things, AD and AE, which are again equal because AD is equals to AE by congruency, by the given congruence, right? Similarly, we can also say that uh, last thing that we need to prove here is BC AB is equals to, we need to also prove something in BC by DE, right? So if these two are equal, there is one last thing. BE. Is everyone following this or everyone is clueless what is happening here? Following so far?
Yes.
Yep. Okay. We need to prove, we have proved one part of the, all right. If we have proved one part, then that's enough, right? Why do we need to go ahead? This is side AB. This is side AC. This is side AB. We have proved it. SAS is done. By SAS, we can say that they are similar. We don't need to move ahead again. We don't need to prove this part. Did you guys understand it? We are done with the question. We do not need to solve for another side because we proved side AB upon side AD is equals to side AC upon AE. The ratio is equal, and then we proved angle A is equals to angle A. And this is what? Side angle side similarity. Because of that, we can say that these are two similar triangles, right? Did you understand how did we use this part? This particular part
Yes.
here? AB upon AD is equals to AC upon uh, AE, right? So a good question for that. All right. So any doubts in this? No, right? Okay. So
No,
we are
sir.
at the end of the time. Tomorrow in the next class, I'm not going to be available on Sunday. So the next class would be on Monday, right? Let me just look at the schedule here. When will be our next class? When which chapter will we start? Oh, no, our next class is on Saturday. It's not on Sunday, it's on Saturday. So we will be doing this class together. Okay. So, all right, in the next class, we will start with surface area and volume then. Okay. And you guys can bring your doubts from any other chapter too. Okay. So see you on Saturday. I will be there on Saturday, right? Yep, I will be on Saturday. Yeah. Okay. So see you on Saturday then. If there are
Okay.
any
Thank you.
doubts,
Thank you, sir.
you're welcome. You're welcome. You're welcome. Take care. See you on Saturday. Bye bye. All right. If anyone has any doubts, they can stay back or else everyone can leave too. All right.